Okay, let's do free body diagram, practice problem 4. We have two cylinders that are restrained between two vertical walls. Total distance between the two walls is 10 feet. So we have define the force on the left wall, find the force on the right wall, the bottom of the floor, and the force between the two rollers, which of course will be equal and opposite. Let us begin. The first real important part of this problem, and here's roller A, and here's roller B, is to find the angle of that force. And there's a number of ways we can do this. I can see this distance is 10 feet. The radius of the roller A is 3 feet, half of 6. And the radius of roller B is 2.5 feet, half of 5. So if I take 10 minus 3 minus 2.5, I have this distance x. Which gives me 4.5 feet. Now if I know this length is 4.5 feet, and I know that's theta, I also know that this distance is 3 and this distance is 2.5. So I also know that this is 3 plus 2.5 or 5.5. So the cosine of theta, adjacent over hypotenuse, is 4.5 over 5.5. In other words, theta equals 35.096 degrees. Now, let's begin with a free body diagram of cylinder B. I have the force from the left wall. I have 900 pounds going straight down. And I have a force from the rollers 35.096 degrees. And those are all the forces that are on the cylinder B. Two unknowns, which means I can solve this equation with the sum of fx and the sum of fy. We'll break the fr, the roller vector, into its x and y components. So I have fr times the cosine of 35.096 and fr times the sine of 35.096. Both of those are positive. One's pointing upwards, one's pointing to the right. Okay, if I look at the x forces, the only other x force is minus FR wall. If I sum those up, they equal 0. The only other vertical force is 900, pointing straight down. So I have one force going up and one force going down. So I can immediately solve for the roller force. FR equals 900 over the sine of 35.096 degrees. And my roller force is 1,565 pounds. Now if I take 1,565 pounds, substitute it into the x equation, I get F right wall is FR times the cosine of 35.096, which means the force on the right wall is 1,565 times the cosine of 35.096, which equals 1,281 pounds. That's half the problem. The other half of the problem is to find all the forces on cylinder A. So here's cylinder A. It has a weight of 1,500 pounds. There is a force on it of 1,565 pounds from the other roller. And of course we know that's at an angle of 35.096. We have an unknown force from the floor and another force from the left wall. Okay, again, this is now 1,565 times the cosine of 35.096 and 1,565 times the sine of 35.096. And of course that replaces this force. Everything else is already in the horizontal and vertical directions. So if I look at the force on the left wall, I sum up my x forces, that's going to the right, minus 1,565 times the cosine of 35.096 equals 0. I can now easily solve for the force on the left wall equals 1,565 times the cosine of 35.096, or the force on the left wall is 1,281 pounds. What a coincidence. If I sum up the vertical forces, I have the force from the floor minus 1,500 minus 1,565 times the sine of 35.096, or FL, force on the floor, equals, just add these two together and move them to the other side of the equal sign, and that is 2,400 pounds. So my force on the left wall is 1,281 pounds. My force on the floor is 2,400 pounds. My force on the right wall is 1,281. And my contact force between the two rollers is 1,565 pounds. And that's our final answer.